Next, we're going to use series to evaluate an integral. Note that integral sine of x squared dx is not an integral that you can evaluate using your standard techniques. So for example, if you try u equals x squared, your du would be 2x dx. So this becomes a difficult integral to evaluate using a u sub. There are ways to do it, but we're going to see here how to evaluate this integral using series. So what we're going to do is start with, okay, we know our series for sine of x is sum n equals 0 to infinity minus 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. And now we're going to say, okay, if I want a series for sine of x squared, I take my series for sine of x, and everywhere there was an x, we put in x squared. So minus 1 to the n, x squared to the 2n plus 1 over 2n plus 1 factorial. So this becomes sum n equals 0 to infinity minus 1 to the n, x to the 4n plus 2 over 2n plus 1 factorial. And now we want to integrate that, so we get integral 0 to 1 sum n equals 0 to infinity minus 1 to the n, x to the 4n plus 2 over 2n plus 1 factorial. So we remember the integral of a sum is the sum of the integrals, so this is just sum n equals 0 to infinity, and now we need to integrate. Remember that the dx means our variable of integration is x, so anything without an x is just going to come out. So the minus 1 to the n over the 2n plus 1 factorial, that comes out. And now how do we integrate? So we add 1 to the exponent, so we get x to the 4n plus 3, and then we need to divide by 4n plus 3 so that when we take the derivative, the 4n plus 3's would cancel. So again, if you're confused about that step, remember if you integrated x to the 7, for example, you would add 1 and get x to the 8, but then you need to divide by 8. So if we integrate x to the 4n plus 2, we get x to the 4n plus 3 over 4n plus 3. Okay, and this is a definite integral, so we're evaluating from 0 to 1. So now when we plug in our upper bound of integration, x equals 1, so we get sum n equals 0 to infinity minus 1 to the n over 2n plus 1 factorial times 4n plus 3. And now we're plugging in x as 1, so we get 1 to the 4n plus 3. 1 to anything is just 1, so we get times 1. And then we would subtract off. If we plug in x as 0, we just get 0, so we're really just subtracting off 0. So our final answer, the integral from 0 to 1 of sine of x squared dx, can be expressed as an infinite series using this sum. And now if you wanted a numerical approximation for this, you would simply say, okay, when n is 0, we get a 1 on top, 1 factorial times 3, so just 1 over 3. When n is 1, we get minus 1 over 3 factorial times 7. When n is 2, we get plus 1 over 5 factorial times n is 2. 2 times 4 is 8 plus 3 is 11. N is 3, we're getting minus 1 over 7 factorial times 12 plus 3 is 15, etc. And this goes on and on. So to get a numerical approximation, you just add up the first several terms of this series. So again, the idea here is that we used an infinite series for sine of x to get a series for sine of x squared, and we then integrated that series for sine of x squared to evaluate this definite integral.